Have you ever just, stopped and thought about how you see things? It feels so automatic, right? Instantaneous. But behind that simple act, there's this incredible mystery, a journey that's happening faster than we can even imagine. So let's do this. Let's solve the mystery of sight together. So seriously, how do you see the world around you? I mean, how does the image of this screen, or your room, or the sky outside get from out there all the way into your brain? Well, to figure that out, we've got to meet the main character in our story. And that main character is, of course, light itself. Before we can get anywhere, we need to understand the number one, most important rule that light always follows on its journey to our eyes. And here it is. This is it, the foundation for everything. Light travels in straight lines. It doesn't curve, it doesn't swerve, it doesn't wander off on its own. Nope, it is a direct, super fast messenger, and this one simple rule explains so much about how we see our world. Now, that straight line journey, it's got a specific wiggle to it. Light travels as what we call a transverse wave. Okay, the best way to picture this is to imagine tossing a pebble into a calm pond. You see those ripples spreading out, right? The water itself is just moving up and down, but the wave is moving forward. That's a transverse wave. Light does pretty much the same thing, except, and this is the wild part, it doesn't need water or even air to travel through. Okay, so we've got light zipping along in straight lines. But what happens when something gets in its way? I mean, the world is full of stuff. It's basically a giant obstacle course for light. And how light deals with these obstacles, well, that's the next huge piece of our puzzle. And it turns out it's actually pretty simple. Every single material you can think of treats light in one of just three ways. They're either transparent, translucent, or opaque. Let's just break down what each of those really means. So first up, we've got transparent materials. Think of these as the green lights for light. They just let it pass right on through without any trouble. A clean window pane, a glass of water, that's transparent. The most important thing here is that you can see a nice clear image on the other side. The path is totally open. Next on the list are translucent materials. Now, these are a little trickier. They let some light get through, but they mess it all up, scattering it in a million different directions. The perfect example is frosted glass. Like on a bathroom window. You can tell if it's bright or dark outside, but you definitely can't make out a clear picture. The light gets through, but its nice, neat, straight-line path gets totally scrambled. And finally, there are opaque materials. These are basically a brick wall for light, a total dead end. Your wooden table, a book, the wall in front of you, they're all opaque. Light just can't get through. It either gets soaked up by the material or it bounces right off. But the crucial takeaway is the journey through the object stops cold. So let's just recap that real quick. For transparent materials, all the light gets through, giving you a clear image. For translucent, only some light gets through and it's all jumbled, so the image is blurry. And for opaque, zero light gets through, so you see no image at all. Makes sense, right? All right, so we know light travels in a straight line, and we know how it handles different kinds of obstacles. But this all brings up another really big question. Where is all this light actually coming from to begin with? Well, it turns out there are only two options here. Objects are either luminous, which means they make their own light, like the sun or a lamp or a bonfire, or they're non-luminous, which is pretty much everything else you see around you. Non-luminous things are only visible because they act like tiny little mirrors bouncing light from a luminous source. Think about it. The moon doesn't have a light switch. We only see it because it's reflecting the sun's light all the way back to us here on Earth. So now we have all the pieces of the puzzle, right? We have a light source, we have an object, and we have our eyes. So how do we put it all together and actually map out that entire journey? Well, scientists have this really simple but super powerful way to draw it all out. And that tool is called a ray diagram. That's it. It's basically just a map that shows the exact path that light takes from where it starts to where it ends up. It's the perfect way to tell the story of how we see any given thing. And honestly, making one is incredibly easy. You just have to follow two rules that, hey, we've already learned them. First, because light travels in straight lines, you draw straight lines for the rays. Easy enough. And second, you just pop an arrowhead on the line to show which way the light is going. And that's the whole thing. So let's use this to build the whole picture. For us to see any non-luminous object, like say the very screen you're looking at this very second, the ray diagram is simple. It would show a straight line coming from a light source, like a lamp in your room, hitting the screen, and then another straight line bouncing off that screen and going right into your eye. And there you have it. The mystery is solved. We don't actually see objects. What we see is the light that has traveled from a source, bounced off those objects, and then finished its straight line journey into our eyes. It's like this constant invisible relay race of light happening all around us all the time. But wait a second. Thinking about all this brings up a whole new puzzle, doesn't it? We've just established this fundamental #1 rule: light only travels in straight lines. So, if that's true, how in the world do mirrors work? How do they let us see things that are behind us or even see around a corner? Well, that sounds like a mystery for another time.